in all of time, on all the planets of all the galaxies in space, nations have risen. Seen what we see. Asked the questions that we ask.
Seems to have conquered every corner of the Earth. How did it emerge?
Living organisms are created by chemistry. We are huge packages of chemicals. Now, what are the ideal conditions for chemistry? You need energy. But not too much. Right about, and planets, it turns out, are just right because they're close to stars. You also have diversity of chemical elements, and you need liquids such as water. Why? Gases. Atoms move past each other so fast that they, in solids, atoms stuck together. In liquids, ooze and cuddle and link up to form molecules.
Liquid water is just so good going. Molecules can dissolve in the water, form more complex chains.
Now, where do you find such Goldilocks conditions? It's great. And our early Earth was built. It was just the right distance from its star to contain huge oceans of liquid water. And deep cracks in the Earth's crust. Fantastic happen, and atoms combined in all sorts of exotic combinations.
Planet, microbes have adapted to survive on most conditions. Arid deserts in Himalayas, in trenches under tons of pressure in the ocean deeps.
New research suggests that life emerged over 4 billion when Earth was an alien and deadly planet. At the time, Earth was ravaged by an asteroid storm that lasted 100 million years. But in conditions, life quickly found a foothold.
As soon as the Earth cooled off after its formation, we know that life began here.
Because it happened quickly here on Earth, we think it's going to on other planets as well.
that the wash in water. It's a wash in organic molecules and all were necessary for life to begin on this planet exists in abundance. Did something similar to what happened on those other planets?
There are more habitable Earth-mass planets, volume of the universe, than there are grains of sand beaches on Earth.
Among this abundant, many will be deadly to life as we know it. There will be planets in the habitable zone that are scorched and suffocated by poison gases. Many will lack an atmosphere, critical for temperature regulation, or have one that is deadly. Venus, once thought to potentially support, now sterilized by a crushing toxic atmosphere. May not be confined to the habitable zone. Far from the warmth of their star, giant gas planets may be hidden oases for life. Their energy comes but from gravity, the lurching push planet. Icy Enceladus has it all, a huge subsurface hydrothermal vent spewing the chemistry of life. Titan is larger than Mercury and speckled with methane lake sounds. In 2026, NASA plans to send a drone to Titan, out signs of life in its valleys and craters.
For years, we've looked to Mars as our best bet for finding the solar system. That Venus could have been habitable in the past is also quite. In liquid water for around 3 billion years, uninhabitable just 750 million years ago. Life could have been present on the surface and ability to float up into the clouds. Up here, the temperatures become balmy, comparable to the life on Venus isn't that crazy.
The discovery of just one Mars, or any other body of the solar system, the whole chain of evolutions, cosmic, chemical, is at work everywhere. In that case, the creation of life anywhere would be more the rule than the exception.
Our lifetime, we're going to understand that there is life on other bodies in the solar system. We're going to understand the evolution of life here on Earth. Find planets around other stars that we can say we see potential signs in their atmospheres. Happen in the next 10 to 20 years. How exciting! We're on the verge of things that people have millennia. Are we alone? We're on the verge of finding that out.
Our universe is close to 14 billion, and there are planets out there that are 3 times as old as Earth. With all that time to develop, there could be life out there far than us. The Big Bang created the lightest elements: hydrogen, helium, and lithium. The heavier elements that make life possible were only in the ultra-dense cores of stars. And for those elements to wind up inside your body, those stars would have to explode. red dwarf stars can live up to 10 trillion years, bathed in starlight for eons. Life is much more probable on these timescales, stable for vast periods of time. Any beings living close to these stars would have to kill solar flares that continually threaten extinction. Many of these planets are locked. One side permanently exposed to the sun, the other frozen in darkness. To have any hope of finding alien life, look for. But where do we begin? How a seemingly infinite set of possibilities. There's one thing we know for sure. Play by her own rules. No matter how strange alien life might be, it's the same physical and chemical laws that we are. On top of this, each alien environment will further limit forms can evolve there. Despite these natural boundaries, the possibilities are stretching. Trillions of planets, a cauldron of chemicals undergoing their own complex evolution. To guide our thinking, this museum will be divided into two exhibits. home to beings with biochemistries like ours, and life as we don't know it, home to beings that shout of life itself. Before we venture too far, we have to ask ourselves, what if aliens are more like us than we think? If it unites us with the other specimens in this museum, it's carbon.
Carbon is one of the most common elements in the universe, and it's very good at molecules.
Carbon has the rare ability to form four-way bonds with and to bind to itself in long, stable chains, enabling the formation of huge, complex molecules. Versatility makes carbon the centerpiece in the molecular machinery, and the same carbon compounds that we found far from Earth, clinging to meteorites and floating in far-off clouds of cosmic dust. The building blocks of life, seen like snow through the universe. And if selected other carbon compounds for their biochemistry, choose from. Scientists recently identified over 1 million possibles to DNA, all carbon-based. If we ever discover other carbon-based life forms, we would be fundamentally related. They would be our cosmic brethren. But would they look anything like us? If they hailed us, we could share even more in common than just our body.
What would life be on planet if it is evolved? Would it be like the world today here, or would it be completely different? There are you that from the argument of convergent evolution, if conditions are to appear, then we would see very similar life forms. Animal and systems that look very familiar.
On Earth, certain features like eyesight, echolite have evolved multiple times independently in different species. This process of convergent evolution could extend to alien planets like Earth, where creatures face similar pressures. But there could be certain universalities of life. The greatest hits of evolution across the universe. Each feature would be attuned to its local environment. Dimly lit planets would produce huge and extra light, like nocturnal mammals.
Some people have gone so far that human-type organisms, humanoids, will occur on other planets.
The existence of other human-like organisms seems unlikely, given the long chain of events that produced us. But we can't. Every 100 trillion Earth-like planets produced a human-like, there could still be thousands of creatures like us out there. Convergence is also rampant in plant life, and C4 photosynthesis independently over 40 times. Would alien plants look like ours or something else entirely? On Earth, plants appear green because they absorb the other wavelength light spectrum. Come in many colors. And alien plants would evolve different pigments to adapt to their terrain. Plants feeding off would appear redder by absorbing their energy-rich bluer. Around dim red, vegetation could appear black, adapted visible wavelengths of light. itself appeared purple due to a pigment called retinol that was an early chlorophyll. Some think molecular simplicity could make it a more universal pigment. If so, we may find is life's favorite color. But the color of vision is more than just a curiosity. Nation that could be seen from light years away. Earth plants leave us in the light reflected off our planet. Finding from another world could point the way to alien vegetation. Perhaps our first glimpse at alien life, a vibrant cast by a distant world.
Change the day length of a planet? What happens when you change the tilt of a planet, the shape of the orbit? What happens when you change the gravity of a planet?
Planets with long orbits would see drastic seasons. Could be worlds that appear dead for thousands of years, spring to life. Most of the rocky planets discovered so far have been Earth's. How would life evolve on these worlds? In the seas, gravity may not.
A high gravity planet all over. If you're in the sea, and that's where all life starts, very nearly no gravity because you're much the same density as the stuff around you. It's when the animals come out on land, gravity.
High G-forces would necessitate large bones and muscle mass life on land. They would also dust circulatory system and plant life by the energy cost of carrying nutrients under stronger gravity. Low-gravity planets would more easily lose their atmosphere and lack a magnetic field to protect from cosmic rays. Worlds could be home to secret oases. Cave systems that provide hideouts for life. The smallest possible habitable planets are estimated at 2% Earth's mass. If surface evolve on these worlds, it could be a sight to behold. Plant life could grow heights, able to carry nutrients higher in lesser gravity. And without the need for bulky muscle mass, animals could have body types that boggle the mind. Here on Earth, it took 3 billion years for evolution to produce animal life. Simpler organisms, more adaptable, and more widespread. The largest collection in the museum would likely be the Hall of Microbes. Yet finding the alien microbe would be a profound discovery. And bites leave a big footprint. Lights on Earth layers of microbes could build up into huge rock mounds, leaving behind eerie structures. And in big enough numbers, some area could leave a distinct biosignature. Gases that wouldn't coexist naturally, like oxygen.
There's ways to make oxygen without life, there's ways to make methane without life. The atmosphere together is almost impossible unless you've got biology making those. And it would have an imprint on the planet's spectrum of color.
Next generation space telescopes could find a signal on a world not far from home.
The closest sun-like star with an Earth-like habitable zone is probably only 20 light years away, and with the naked eye.
Brown dwarfs are too hot to support life as we know it, just cold enough. All the prime element detected inside their atmospheres. And within these clouds, some layers would provide ideal temperature habitability. Be photosynthetic plankton in these skies, kept along upwinds. And with enough force, these upwinds could even support complex life. This raises a crucial question. What if we've been looking in all the wrong places? What if nature has other ideas? The universe is too cold or too hot for liquid water and thus supports life as we know it. But in case our biases are misleading, we have to to search for life outside that, in places that seem wildly hostile to us. Exotic environments, exotic biochemistries, and while no element can match carbon, one contender is a frontrunner. At first glance, silicon seems similar to carbon. It forms the same four-way bonds and is also first. But a closer look reveals elements are false twins. Silicon bonds are weaker and less prone to forming molecules. Despite this, they can withstand a wider range of temperatures. Intriguing possibilities.
Life based on the silicon atom instead of carbon, resistant to the extreme cold, providing a whole range of weird forms.
Silicon has a problem. In the presence of oxides into solid rock. To have known, silicon beings might be confined to oxygen-free environment, Saturn's frigid moon, Titan. Its vast lakes of liquid methane and ethane, medium for silicon-based life, or other radical Without ample sunlight, beings on worlds like Titan be chemosynthetic, deriving their energy by breaking down. Such life forms could have ultra-slow metabolisms and life cycle millions of years. temperatures, typically rigid silicon-oxygen bonds become more flexible, triggering more dynamic chemistry. This has led to a bizarre proposal: silicon-based life forms that molten silicate rock. These forms could even exist deep beneath the Earth inside magma, part of a shadow biosphere. If so, then the aliens are right on. Biospheres have been proposed, forms of life living alongside us here, including tiny RNA-based life small enough detected by existing instruments. Clouds of dust in empty space might seem like the last place you'd live in. But when cosmic dust plasma, a type of ionized gas, something strange happened. Conditions, dust particles have been seen spontaneously self-orbital structures that resemble DNA. These plasma crystals even begin behavior, replicating, evolving into worms, and passing on information. Plasma is the most common state of matter in the universe. If complex evolving plasma crystals really exist and be considered life, they could be its most common form. Massive suns explode, some collapse into ultra-dense core stars, hulking masses of atomic nuclei crammed in. Just are mind-boggling. Gravity is 100 billion than Earth's. In our nuclei crust lies something strange. Hot, dense sea of neutrons and subatomic particles. Stripped of their electrons, these nuclei would obey entirely different laws of chemistry, based on magnetic force, but the strong nuclear force, which in theory, could link up to form larger macronuclei, which could then combine bigger supernuclei. If so, then this bewildering environment would mimic the base life. Heavy nucleon molecules floating in a complex. Some scientists have proposed the unimaginable, exotic life forms drifting through the strange particle sea, evolving and dying on incomprehensibly fast timescale. Life is not something naturally be designed. And once intelligence is introduced into the evolutionary process, Pandora's box is opened. Typical biological limitations, synthetic and machine-based, most successful of all. could thrive almost anywhere, including the vacuum of space, vast frontiers unavailable to biological organisms. And compared to the glacial pace of natural selection, technology allows exponentially faster growth, adaptability, estimates, autonomous self-replicating machines could colonize in as little as 1 million years. We can't predict how Hyper would organize itself. But in theory, there could be convergent evolution at play. The electrical properties of silicon might make it a universe machine intelligence, a redemption for its biology. As the universe ages, perhaps will come to dominate, and naturally occurring biological viewed as a quaint starting point. Perhaps we ourselves position, and the great human experiment will be merely a sprawling intergalactic chain of life.
Has said that one does not move until one catches the reflection from an eye other. One day that eye may be an intelligent alien. We eschew our narrow view of evolution, the sooner we can truly explore origins and destinations.
most complex object known is the human brain. These 86 billion neurons have given us the power to our planet. But is this the best nature can do? Oh no, there are something like 10 billion trillion habitable verse. 10 billion trillion chain to be eclipsed by something else. The search for intelligent life is more than just a curiosity. It's driven by a deep with something greater. Finding an alien civilization wouldn't just reveal we're not alone. It could chart of evolution for our species. And unlike primitive life, alien intelligence could be detected light years away, making them potentially easier to find. What do they know that we don't? And how do we make contact? We're not the first to wonder. So, we dreamed of lighting huge rings of fire in the Sahara Desert presence. 60s, a French poet proposed a patchwork of giant mirrors reflecting sunlight to Mars in the form of the Big Dipper. But if you want to send a signal across space, bonfires and reflected sunlight won't help you much. Even a nuclear war on a near would be virtually impossible to detect with current technology. To recross, you need a form of light you can't even see. Radio waves are ideal for information long distance, because compared to other forms of light, freely through interstellar gas and dust. SETI, the search for extraterrestrial intelligence, has entirely on scanning for radio signals, whether intentional or byproducts of technology. Our own radio transmissions have now traveled light years and reached 75 star systems, which include potentially habitable planets. And if alien intelligence lies beyond this bubble of signals, for life on Earth by spotting oxygen in our atmosphere. Institute and the recent Breakthrough Listen project, we have now tens of millions of stars for signals. But despite all this, after 6 decades, nothing. Only a series of false alarms and dead-end. We call it silence. The search has barely even begun. There are 2 trillion other galaxies out there that are still too for practical study. The size of all Earth's oceans, we would have searched less worth of water for signs of intelligent life. We might even be looking for the wrong thing. More than one way to communicate across space. An alien life might view radio as primitive technology. We have to consider every possible alternative, from the practical to the unimaginable. The search is now underway for a different one we could even spot with the naked eye. Laser light. Powered laser bursts can outshine a star by thousands of times, carry far more data per second than radio. Have to be in direct line of sight to detect the beam, but spread across many light years, they would widen to entire planets and moons. Fleets of laser beacons sweep the entire galaxy, like is in a cosmic sea. Thanks to a recent effort, plans are now in motion to monitor the entire night's pulses. But while these bright, relatively easy to find, advanced life might be using something more elusive. Neutrinos. Tiny subatomic particles that are streamed to trillions every second. Ghost particles can pass through entire planets and single atom. It takes a giant to detect just a handful of them per day. But researchers recently proved neutrino communication is possible, sending a simple message through 240 meters of rock. If advanced life is using them to communicate, signals could travel anywhere, through any obstacle, at the speed. Their messages could be streaming through us right now. We would have no idea. Or maybe intelligent life, an entirely different approach to communication. Space-time itself as a medium. By manipulating high-gravity object theory, create pattern distortions of space-time, which could reverse in all directions. But making gravity waves strong enough to be extremely energy-intensive. Maybe they're up to something far simpler. Placing giant orbit around a star could block out starlight in distinct, like a kind of cosmic Morse code. And even though it might blink out a basic message, a system like this would require sustain. But the most sci-fi possibility of all is that they have left in our DNA. Some of the sequences of our genes could contain hidden messages, or eggs in our genetic code, placed by a life-designing house. Far-flung scenarios like this are overshadowed by a more sober, wrong place, at the wrong time. Using a detailed computer model, researchers have estimated that intelligent life was possibly 4 billion years ago, and closer to the sun. Then we would exist on the outskirts, light and billions of years too late to a galactic golden. Maybe they were here, millions of years ago, witness to a whole different planet. By now, they might all be, and we could be living in a galactic graveyard. It may not be their signals that we find one day, but their out, our chances of finding an alien civilization depend heavily on survival time. If the average lifetime 100 years, then they will blip in and out of existence, lapping, and our chances of finding one alive are slim. But if they survive for thousands of years, our chances will skyrocket, as the potential for overlapping. They're not communicating at all. A way we could find them. We that alien intelligence would share our motivation to communicate. But they may find the prospect too dangerous or too futile. If this is the case, then we have to get more creative in our... In 2015, astronomers' normal-seeming star began to dim in erratic ways than they'd seen before. The cause is a dust cloud or a shattered moon blocking the light, but it harks of something else. An alien. And even nation looks unlikely, it hints at a new way of finding it. Not listening for signals, looking for their technology directly. Searching for messengers, but searching for engineers. And to do that, wonder, what mind-boggling alien technology for? Civilization would be wildly different, but classifying the usage will give us insights into what technology they might be using. The Kardashev scale divides them into Type 1 would have a mass planet, using all the energy available on it. Type 2 would have mastery over their star, all its solar energy. Would have mastery over their entire galaxy, and would be us than we are to amoeba. But before we go in super technology, how would we find civilizations like our own to reach Type 1? When a typical planet passes in front of it, see the starlight dim sharply. But observing the fall-off of starlight could be evidence of a dense ring of satellite, a Clark belt. Spotting this type of light curve wouldn't be but rings around rocky planets are unusual. They could point us in the right direction. Vegetation would leave a biosignature in its atmosphere. It would leave a technosignature. It produces a recognizable light curve similar to chlorophyll. Spotting this signal could point us to the presence of alien solar. And something more nefarious might also foreign atmosphere. Alien pollution. Certain pollutants like chlorofluor produced by nature and could be detectable even in small. These chemicals linger long after a civilization dies, us to the remains of an extinct alien race. Such a discovery could give us crucial guidance, our own extinction. And there's another universe to be familiar with. Any civilization that uses produce huge amounts of waste heat. Excess heat could prove a serious threat, just as climate change does. But it could also leave a telltale. Finding waiting from alien planets or other regions of space could point to urgent activity. If not exterminated by their own technology, forms may achieve total control over their planet and become a Type 1 civilization. With this mastery would come incredible powers, control over all their world's ecosystems, and even its weather. But no matter how advanced, every planetary civilization faces the same cosmic threats we do. Gamma ray bursts, supernovas, and asteroid risk factor for any terrestrial race. Some might decide to flee to intergalactic, reducing their exposure to existential risks. In the voids between the stars. If so, then our search will have to entire swath of the universe. But alien life that decides to will need long-term protection. best way to protect your world in home defense. Planetary shield. Cause a telltale dimming pattern during transit, a detectable heat signature. Large-scale asteroids would require a colossal amount of resources. The easiest way to get them may not be from mining planets, but from mining asteroids. They are resource-rich, manipulate because of their lower gravity. Searching distant asteroid fields for chemical anomalies could indicate alien mining activity. So, asteroids might not be enough. Since our civilization is so new, any other intelligence is likely to be more advanced than us. So we should think twice revealing our presence. But alien super-civ won't just be looking for resources. They need staggering amounts of energy. Stars output billions of times more energy than planets. To harness it all requires building something mind-boggling. Spheres are enormous megastructures that encircle a star, designed to capture its entire energy output. They could also double habitats for life. It would be physically unstable, so instead of the sphere, a cloud of objects, a Dyson. No matter their design, they would generate of infrared waste heat. And they could also eclipse or even stars' light entirely. Dyson spheres could own black holes, which could have a smaller radius and collect times more energy. Beings that come to harness their star's entire energy output to the next level on the Kardashev scale. A Type 2 civilization. This level of mastery would imply instability. Star lifting is the practice of harvesting stellar material to provide thousands of planets' worth of resources. This process would also allow you to of a star, postponing its death by billions. 1 billion years' time, our own sun will grow too hot. If we ever find evidence of it, could inspire us to one day do the same and prolong the game of life. Eventually, be life that outgrows its star and more energy. To branch out across life forms this advanced will probably need near lights. And if they do, there's a chance we could catch them in the act. Alien starships that hit the brakes at lights could leave behind a long trail of ionized gas. These trails detectable infrared radiation. strokes of light, masters of the universe. Once life is all the energy their galaxy can provide, the unimaginable power, civilization. Cosmic virtuosity would be totally unfathomable to us. Life that has built billions of Dyson sphere stars at will. In theory, their thirst for energy could make a whole go dark. So one way to search for Type 3 life form for what's not there. In space, there are huge voids between clusters of galaxy light emanates. Were once thought to be evidence of advanced life having harnessed the every star in the region. But it turns out there are naturally occurring features of the, and a recent analysis of nearby galaxies, evidence of any galactic scale civilizations. In theory, cosmic architecture, enormous planetary systems, far more intricate than any Zeus. One possibly gravitationally stable involves 9 sun-like stars for a massive black hole, which could support 550 in a habitable zone. These artisanal solar systems could long-term habitats, or could an alien nature reserve, with each planet hosting a different life. It's hard to imagine any life forms more advanced. But in theory, they control or created our universe itself. Researchers are the idea that reality itself is just a simulation and run by some higher order being. Anything this advanced would treat ideas of life itself is outside of time and space. In a way, intelligent life is an evolution of the age-old search for God. Both are driven for truth and connection with something bigger than ourselves. Do find a signal one day. What ancient dream becomes a reality? Just knowing they're out only change how we see ourselves. For the first time, we would feel a cosmic brotherhood. And studying their methodology could lead us to huge advancements and help secure term survival. Possibility of meaningful two-way communication would be bleak. Separated by hundreds or thousands of light years, studying these civilizations as they were in the deep past. experience of language could be entirely foreign to them. But what if, after all our searching, another sign of intelligence? Are alone. We can never be truly sure, as there will always be distant galaxies to ever study. Finding any evidence would mean that our place in the universe is true. It would saddle us with an immense responsibility to keep the flames alive. Just as ancients speak to us through their monuments, we could build monuments of our own life to discover. Cosmic time capsules preserving a record of our achievements. Perhaps other races will do the same, and these could become connected over time, each new civilization adding a link. It could be our destiny to be the first chain, to be the founders of encyclopedia, built upon by future life we'll never meet.